All right, I have some examples of how we're going to use the logarithm rules to solve some equations involving x. And like I told you before, the x would be in the exponent, so we couldn't solve these prior to this. So I'm going to show you how to solve them. And then there's two catches. The textbook is going to ask you to leave your answer in two different forms. One in calculator ready form, and then use the calculator to get the decimal answer. And you'll be required to show both on your paper during the test. So here we go. First thing you do, got something like this and there's no way to solve for x, so you take the log of both sides. So the log of 3 to the 2x equals the log of 5. Now, when I don't write a base on the log, I'm understanding that you're using base 10, so keep that in mind. What's nice about base 10 is your calculator will figure out logs that are in base 10, but no other bases. So, next step, let's use the exponent rule. This 2 to the 2x could be written in front. So I'm going to write 2x log 3 equals log 5. I didn't change the value, I just rewrote this side. It's like adding like terms on the same side, so to speak. All right, I'm solving for x. So to get the x by itself, I could divide both sides by log 3. So let's do that. Log 3. So now I have 2x equals log 5 over log 3. Do not mistake that by writing log 5 over 3 like this. Log 5 over 3. You cannot do that, and if you do that, the answer will not be correct. So you have to keep it in that form. Now I still need to get rid of the 2. I can divide both sides by 2. Another way to divide by 2 is to multiply by 1/2. When I do that, now I have a nice answer. I have 1/2 log base 5, or 1 over log base 5, and 2 log base 3. I mean log 3, not base 3. And then, this is what's called calculator ready. Then, you get your calculator and you can plug it in and get the answer. And in this one, when you plug it in, you should get 0.733. 0.733. Try that with your calculator. Log 5, make sure you close the parenthesis. The log parenthesis has to be closed. Divided by, and then I would put this whole thing in a bracket just to be extra careful. So do that. You should get that for an answer. Mess with your calculator until you do get that, and know how to use your own calculator, because I'm not going to help you during a test. All right, let's try the next one. Now you might want to try this next one yourself, so stop the video and then watch it after you get your answer and see if you get the right answer. All right, here I go. Take the log of both sides. Log 4 to the x equals log 50. Please show me all these steps. Now I'm using the exponent rule. X log 4 equals log 50. Divide by log 4. So x equals log 50 divided by log 4. Now, you can plug that into your calculator, and hopefully you can get an answer. 2.82. Again, make sure you can get the correct answer on your calculator, or come see me for help. All right, so let's solve this last one here. So, first thing I'm going to do is take the log of both sides. Log 9 to the x equals log 3 root 3. Move the x in front. So x log 9 equals log 3 root 3. X equals log 3 root 3 divided by log 9. Now at this point, it's calculator ready, and you could plug it in and get a decimal. But what if I say solve, no calculator? Then you got to do some more maneuvering here. Watch what cool things you can do. I could rewrite this as log 3 plus log root 3 all over log 3 squared. Agree with that? I use the exponent rule here. I use the MN rule to separate these. Now I'm going to put this 2 out in front. I'm going to do more too. Watch this. Log 3, can't do anything with. But I could call this log 3 to the 1/2. Exponent 1/2. All over 2 log 3. You know why I can move the 2, right? Then I'm going to rewrite this one more time, move the 1/2 in front. So I have log 3 plus 1/2 log 3 all over 2 log 3. Could I add like terms? 1 log 3 plus 1/2 log 3? Oh yeah. So I could call that 3/2 log 3 all over 2 log 3. Guess what? I can cross out log 3 with log 3 because it's really 3/2 times log 3, and this is 2 times log 3. So log 3 can cancel out. Make sure you can write it as a multiplication before you go canceling out. Now, 3/2 divided by 2. So 3/2 divided by 2, or times 1/2, equals 3/4. Final answer. Didn't need a calculator. How cool is that? You can do that kind of stuff. Okay, one more example. If you were asked to factor this problem, that's a no-brainer, right? 2 parentheses, x and x for the x squared, 10. 10 and 1, 2 and 5. 2 and 5, minus 2 minus 5. So x equals 2, x equals 5. I skipped a step, hope that's okay. So that's easy. This one looks really scary, but if you think about it, that could be your x, and that could be your x squared. So it really factors. Let's do a substitution. Z squared minus 7z, let's make that plus 10. Plus 10 equals 0. So z minus 2, z minus 5, but z was really 8 to the x. So 8 to the x minus 2 and 8 to the x minus 5. Those are the answers. So 8 to the x equals 2. 8 to the x equals 5. In this problem, we were done once we got x equals 2 and x equals 5. Well, I still have to continue solving this for x. Here's the catch. Here's where logs are your best friend, because now I can take the log of 8 to the x equals log of 2. Move the x in front, so 8 log 8 equals log 2. X equals log 2 over log 8. And 8 is 2 to the third, so it's log 2 over 3 log 2. Log 2's can cancel out, 1/3. Final answer. Okay? On some of these, you'll be allowed to use your calculator. Sometimes you can't get to that nice final answer. Let's try this one. So again, let's erase this. And we'll start over. So I do log 8 to the x equals log 5. X log 8 equals log 5. X equals log 5 over log 8. And even though I can simplify 8 as 2 to the third, I really can't get rid of the log 5. So on this one, I could rewrite this as log 5 over log 2 to the third. And I could write it like this, log 5 over 3 log 2. And that's about as far as you can go. So sometimes you can get a little bit further.